In this session, we're going to talk about n-way ANOVA. N-way ANOVA is very similar to a one-way ANOVA. It simply means that we have multiple independent variables. So, for example, let's say we're having participants rate some advertisements. And we show some advertisements to both men and women, two different types of advertisements, and of course gender, we have multiple genders, and so we look at the effect on the ads. And so what we have are two independent variables, gender and ad type, and one dependent measure, in this case attitude towards the ad. So this is a two-way ANOVA. N-way simply means it's more than one. You could have a two-way ANOVA, three-way ANOVA, etc. So let's look at a specific example. What I'm going to do this time is use a different set of pull-downs. Before, when we had a one-way ANOVA, we simply went to compare means and one-way ANOVA. This time, however, with an n-way, we have to use a different set of pull-downs. We're going to use analyze, general linear model, and univariate. So here, this is going to look similar to what we had before. What I'm going to look at is rent as a function of two independent variables, both the housing type that we looked at before, so this is our independent variable referred to as a fixed factor here, and I also want to look at it as a function simultaneously of gender. Now there are different types of models that we could look at, and for students that have had the experience in prior classes, you could look at the interaction between type and gender. In other words, how the effect of one depends on the other. We're going to look at a simpler model here, but I first need to show you how to specify the model. The default is for what's referred to as a full factorial. That would look at type and gender as well as the effect of type on gender. We want to look at a more simple model. Specifically, we want to look for the main effects of type and gender. Click Continue. The other thing I want to do is visualize the data, and so I'm going to ask for a plot. In this case, I'm going to ask for type on the horizontal axis, gender as separate lines, and you'll see in a second what that looks like. Continue, and then OK. So again, as before, the first thing I want to do is inspect my data visually. And here we see from a prior session the data about housing type, and we see how that varies as a function of the type. The rent varies with the type of housing. And we have a separate line here. We have the data for men and for women, the blue line and the green line. It looks as though there isn't much of a difference between men and women, but let's see what we find statistically. So this is where we want to focus, the test of between subject effects. First of all, we want to look at the overall model. Is the overall model statistically significant? Our F-test, based on this degrees of freedom of 2.4, is significant p less than 0.05. Barely, but it is significant at p less than 0.05. So the next question is, which of our predictors are significant? Well, the intercept term is significant, but what I want to focus on here really are each of the individual predictors, type and gender. It looks as if type is significant. F of 2.97 with 4 degrees of freedom. Significant at p less than 0.05. And as I suspected when I inspected the graph, gender is not significant. F of 0.09 with degrees of freedom 1. And a p-value that is above the 0.10 threshold. So that's just an example of an n-way ANOVA, in this case a two-way ANOVA, and illustrates how we can simultaneously look at two predictors that are categorical in their effect on a metric or scale ratio dependent variable.